In assignment 3, we are going to talk about doing profiles, how to figure out what size you need for your stock when you're doing a profile, and how to start engraving at different depths. This is by far the most challenging assignment so far. We have to do a little bit of math to figure out our job size, and there are going to be multiple tool paths that are actually a little complex. Our first step is going to be figuring out what job size do we need. To determine that, we need to first decide how big do we want our coasters to be. I'm going to do a 4x4 coaster. This is why what kind of profile you do makes a difference. So when you profile, you follow a line. But what we haven't talked about is the different ways you can follow a line. You can follow a line so the end mill is actually on that line, like in this example. Since the end mill is actually on the line, you lose half the diameter of the end mill on this side and half the diameter on this side. That results in a total loss of the diameter of the tool. If we were using a 1/4 inch end mill and we drew a 4x4 square, we would lose the whole diameter, which is 1/4 inch. So we would get a part that ends up being 3.75 by 3.75. Again, I'm getting this number because since we're losing half the tool diameter here and half the tool diameter here, the total loss is the diameter of the tool. So my part dimensions minus tool diameter. Another way that this can follow the square for a profile is by having the tool on the inside of the square. In this example, we lose the whole tool diameter here, and as it cuts out the square, we lose again the whole tool diameter here. So in this example, when we cut inside the line, we lose 2 times the tool diameter. So 0.25 times 2 equals 0.5. So we lose 0.5 on our width and 0.5 on our height. So our actual coaster in this example would be 3.5 by 3.5 due to the loss of 2 times the tool diameter. The last option that I have is cutting outside the outside the drawing. When I cut outside the drawing, I get no loss. So I don't lose anything, so the actual dimension equals whatever I drew. In order to get a specific coaster that's a specific size that you want, you're probably going to want to design it this way. Having the tool cut outside the line, so you're left with a coaster that's the exact dimension that you drew. So I drew this as a 4x4 box. It cuts outside the line, so I don't lose anything. If you want to cut out something to a specific size, you're going to want to profile outside the line. If you want to cut, for example, if I wanted to cut a 4x4 square inside something, then I would probably use the inside the line box. But when you're trying to cut something out that's a specific dimension, you're probably going to want to do outside. I usually only do on the line if I'm doing something decorative, like a line in a part or something. So now I need to figure out what am I going to set my job size to. And this is why this coaster project is a little bit difficult. You need to do a little math. So my first step is figuring out how big do I want these coasters. I'm going to make my coasters 4x4. You can make your coasters whatever size you want. It's really not that much work to do your calculations, so don't be scared to make it 5x4 or 4x3 or 6x6. Make it something that you want. I start all my drawings, or I start all my programs by drawing out what I want it to look like. So I would draw these 4 squares, and I start plugging in numbers. I know that I want a 3/4 inch or 0.75 inch clearance. And I'm telling you that you must have that clearance. You have to have that clearance because we need room to put the clamps. 3/4 of an inch or 0.75 is more than enough room so that we'll have adequate area to clamp. And we want that clearance in the width and in the length. So I take 0.75 and I have to add 0.25 to it. 0.25 is the tool diameter. Then I'm adding my 4. It's going to cut on the outside, right? So I have another tool diameter here. Then I have another clearance because we don't want these two to touch. So I have to have my clearance again. Then I'm cutting on the outside. So I have my 0.25 again. I've got my 4-inch. The tool is cutting on the outside, so I have the tool diameter again. And then I have my final clearance. I like to draw this out because now I see it nice and clearly. There is a way to write this out in an algebraic equation and then you just plug in the numbers, but especially if you struggle with math, this is much, much easier. So my advice when you are figuring out what you want your specific project to be is to print this out. I'll post it on Google Classroom and then you could just change these numbers and add everything up, or draw this yourself. All the red and green are constant. You cannot change that. You're all going to use the 1/4 inch end mill, and you're all going to have a 0.75 inch clearance. That's not going to change for your project that you're going to make. On the test, I am going to change it so you have to do out the math, so I know you understand how to get the answer. But for the physical one that you machine, you're keeping these red and green values. Theoretically, if I used a different size end mill or I changed the clearance, then the values would change. But for the ones that you actually do, that we're actually going to make out of real wood, these values stay the same. And the only values that you might change are the 4-inch by 4-inch. So if you wanted a 5x4, you would change this to 5. And you would change these top ones to 4. Make sure you make it what you want. Don't just copy what I have. When I add all of these guys up, I end up getting 11 1/4 by 11 1/4. Now that I know what my job size is, I can go to VCarve and have an 11 1/4 by 11 1/4 project. Before you go any farther, you probably want to check with me especially if you don't do a 4x4 inch coaster. If you want to do a 5x5 or a 5x6 or something, definitely do it. But call me over so I can check your job size and make sure all your math is correct, because I don't want you to spend all this time designing something and then find out that you made a mistake right here. So call me over at this point to make sure the job size is okay if you changed it, which I do encourage you to do. So I put in my job size. I want to start drawing. So I do my 4x4. And I'm going to put a radius on this so it looks a little nicer. And I'm going to make 4 of them. So I can get the spacing right, I'm going to put a 1/4 inch square on there too. So I place these correctly. And then my clearance. So I want to make sure I have enough room. So I know I want this is my 3/4 inch box. And then I want my 1/4 inch away because the tool is going to cut on the outside. And I'm going to place this square a little past it. It makes the most sense to line up the one above it too. Now I know that which is the correct distance away from this side. I'm just going to take these and move it over to the right side now, so I can set these two guys away from the right side. Now I'm going to do my top and bottom. This one's was a tad off. Once I use this to set my top and bottom, I know the middle has to be correct, because if the top and bottom spacing is right, it forces the middle to be correct. Notice I do have like this small little gap, but with my clearance here that's built in, I'm not concerned. That's why we have a clearance. I know it's going to be okay. It's pretty close, so I'm not concerned about it. So in this demonstration, I'm using these two squares as basically a spacer. This is the end mill, this is my clearance. So now I have my correct job size, I have my correct spacing, and I can actually make these coasters. I'm not going to design all 4 coasters because that may take a long time, and after you do one, you should know how to design the others. One of these coasters, I do want you to experiment with start depth. So I want you to do a recess, which you're going to make using a pocket. In order to pocket, you're going to need an end mill. Let's stick with that 1/4 inch end mill. So I'm pocketing out this circle, which is pretty common for a coaster to have something like that. In this example, I'm going to go shallow, 0.2. I've got my 1/4 inch end mill. And you always want to have ramps turned on when you do a pocket or a profile. It's just good for the tool. And I want to name this because this file is going to have a lot of different tool paths. So I will say circle pocket. If I drew 4 of these, I could hold shift and pocket all of them with one tool path, just so you know. And now the end mill is making this pocket. Now let's say I wanted to put a little picture here with something, or I wanted to engrave a letter, or anything like that. You don't want the bit to engrave starting at 0 on the Z, because we're already 0.2 down. If you start engraving at the 0, it's going to be machining the air, and it wastes time, and it's just not efficient. So somewhere in your design, I want you to have a engraving that has a start depth that is not 0. I'm going to do a very simple design, but you could do really complex things. You could find a little picture online and then engrave it on this. It's up to you. You can take it as far as you want. But for the video, I'm just going to do something quick for the sake of time. So I put the J on there. I'm going to V-engrave it. In my start depth has to be whatever I recess this at. So if you recess it down 1/2 inch, it should be 0.5. I only did it 0.2, so I'm going to have 0.2. And now it's asking you, how much deeper do you want it to go? I don't want it to go another 1/2 inch deep because this is only 3/4 of an inch. And if I go the 1/2 inch deep, it's going to be really thin. So I'm going to go another 0.2. I have my 90-degree V-bit. And I'm going to put this as the J. Engraving. Now you can see it does the pocket, and then it does the engraving, which is what I want. This order here is the order that it machines. Make sure that's correct. For example, your last toolpath would be profiling on the outside of all these squares. So if I hold shift, I can select them all and profile them all at once. I have the ramps on. I want it to go outside. I don't want the V-bit, I want the 1/4 inch end mill. There's a little trick to this. We don't want to cut all the way through. Our cutting these out, your cut depth is going to be 5/100ths less than your actual thickness of the wood. So you have to get a dial caliper, measure the actual thickness, and then your cut depth will be 5/100ths less. So you'll have to do the final cutout with a bandsaw. We want to do this because if your actual thickness is, let's say, 0.75, and then you cut out 0.75, the end mill is going to end up hitting the machine bed on the CNC machine and then putting marks in it, which we don't want to happen. So we always go a little less than the actual thickness, and we'll just finish the rest by hand with the bandsaw. And we hit calculate. And now I can see what it looks like. As you can see, it doesn't cut all the way through. Like I said, we'll have to finish cutting that by hand. I don't want you to hit the bottom of the CNC machine. I want to point out the order of the tool paths. First, I do my recess, then I do my engraving, then I cut it out. You don't want the cutting out up here, because if you cut all these out first, then when you do your engraving and things, it's going to move all around, which we don't want. So make sure this is in the right order. The recess first, then the engraving. To change the order, you can just drag and drop. When you go to actually machine this, you're going to have to machine, or save I should say, 3 different files, because the CNC doesn't support automatic tool changes. The first thing that we do would have to be to recess it. If you only have one recess, it's okay. You could have recesses on all 4 or just one, but you do need at least one in order to fill the requirements of the assignment. Then you're going to do your engraving, and then you're going to have to cut it out. So you should save it as 3 different files. When you save it, you'll click one at a time and make sure it makes sense. So I would save this one. You'd save this to the flash drive too, of course. I'll save it as Fernandez Coaster Recess. So when you save this, you want to make sure that you save it in a way that when you go to machine it, you know which one to do first, second, and third. So I'm going to save this as my initials and then Coaster 1. I know this is the second operation to do, so you need to make sure it's checked off. And then you save it. And then I'll do my initials Coaster 2. And this is the last one, so I'll save it as my initials. And then Coaster 3. For the actual assignment 3, each coaster should have at least an engraving. So you could put letters, numbers, you can go online and put pictures on here and then engrave it. I don't care. But you do need one engraving on each coaster. You have to make at least 4 coasters, and at least one of them needs to have some sort of recess like this one has. A recess, you need the recess because I want one of the engravings to have a different start depth. If you do engravings on these and you don't do the recess, you need a different engraving V-carve toolpath, because this start depth is 0.2, right? If I don't recess these, if I just put, for example, a JF on this one, and then a T here, I can't have one engraving doing all 4. And the reason is this start depth would be 0 because there's no recess in this scenario. So when you do these 3, I hold shift and I can select them all. Start depth is actually 0, not 0.2. And again, the reason is because there is a recess here, so the start depth is 0.2. But here, there are no recesses, so my start depth would be 0. And I'm going to call this my engraving for coasters with no recess. This is why I stress that you should really label your toolpaths so they make sense. So that way, if you have an issue, you can follow it. Here I would move this up to go before the cutout. And now if I saved it in this scenario, since these two use the same tool, I can have both of them checked. Because they're one after another and they use the same tool, so I would actually save it like this. This coaster assignment is definitely the most complex project that you've done. I'm asking you to do a lot of things. I want you to have at least one recess because I want you to have at least one engraving that has a start depth that is not 0. I'm asking you to make 4 different things. You have to do tool changes. It is a big project, and it's going to force you to apply all the different things that you've learned in assignment 1 and 2, and do some math, and do some new operations. If you have any questions, let me know.